This is a lesson on concentrations of solutions. General terms like dilute and or concentrated are general but not very useful. Dilute, how dilute? Dilute means not a lot of solid dissolved in the solvent. Concentrated, that means there is a lot. But what is a little, what is a lot? Much more useful is a numerical value, and there are many of these, 5 that we're going to do in this course. There are others. Molarity. Molarity, the symbol for molarity is capital M, which is moles divided by liters of solution. You've had that before. We've used it in this class already. Mass percent, there's no real symbol for that, and that's the mass, and this is moles of solute, and this is mass of solute over mass of solution, the total mass, solvent and the solute put together. There is the mole fraction. The mole fraction has Greek letter chi, and that's moles of solute divided by total moles of the solvent and solute together. There is molality, cursive m, lowercase cursive m, and that is moles of solute over kilograms of solvent. And this is the only one that has the solvent by itself. All the other ones have in the denominator. All the other ones have the solution. This one has just the solvent, so the solute does not matter in this part. And the last one is normality, or normal. Normal is equivalence times the molarity. If it's an acid, the equivalence is the number of protons, or H's. If it's a base, it's the number of hydroxides. If it's a redox, it's the number of electrons in a balanced equation. Okay? Now, you can start anywhere. You can be given all sorts of information. You can be asked for 5 or 2 or 1 of these things. Generally, you're going to be asked for a whole bunch of stuff. Example number 1, you have ethylene glycol, C2H4OH2. You have 20 grams of that substance mixed with 100 grams of water, and you make 115 milliliters of solution. So find the 5 things up above. So you gotta find molarity, mass percent, mole fraction, molality, and normality. One of the things you probably want to do first is to find the number of moles. So change grams of the substance to moles, because a lot of the equations utilize that. So over here we have 20 grams, 1 mole over the molar mass of ethylene glycol, which is 62 grams. So you end up with 0.325 moles. So now you can start putting in some information. Doesn't matter where you go. Molarity is moles, which we have as 0.325 moles over liters of solution. You have 115 milliliters, so that would be 0.115 liters. Do the math, you end up with 2.83 molar solution. And let's just keep going in order. Mass percent is grams of the solute, which is 20, divided by the total number of grams. Water, 100 grams, solvent plus the solute, which is 20. 20 over 120, which is 0.16666, which is 16.67%. Molality is moles, 0.325 moles over kilograms of the solvent. You got 100 grams of water, so you got to make that 0.1 kilograms. Moles over kilograms, and this is the one with the solvent only. You end up with 3.25 molal solution. The normality, well, the equivalence in this case is the number of hydroxides, OH. So you have 2 times molarity, which is here, 2.83, gives you 5.66 normal solution. And the mole fraction, pi, moles of the solute, 325, 0.325 plus the moles of the solvent. Well, there's 100 grams of water, 1 mole, 18 grams, comes out to be 5.56. Plug that in, 5.56, do the math, and you come up with a mole fraction of 0.0552. Mole fractions do not have a label, it's a decimal number, it's like percent without moving the decimal point over. So that's one example. Another example would be if you have some fairly concentrated hydrochloric acid, and it has a density of 1.19 grams per cubic centimeter, and a mass percent of 38%. We are to find the molarity, the molality, and the mole fraction. Now we got to do some assumptions and such first. What we really need is moles, because we need moles of everything. So moles of the solute, but you're not given grams, so you got to figure out how many grams of the solute you have. So what you do is you start with the density, 1.19 grams per cubic centimeter, and assume a certain volume. 100 sounds like a good number. And that will give you X grams of the solution, the total solvent and solute together. Do the math, you get 119 grams of the solution. Well, we don't need that. We need more grams of the solvent. So that's where we use the mass percent. 0.38, change percent to a decimal, equals the grams of the solvent, the solute, divided by the total mass. Cross multiplying, you get 45.22 grams of HCl. It also might be helpful if you start labeling some things so you know where you are doing. Now, what you do is you have to find the moles of HCl. So 45.22 grams, 1 mole over 36.5 grams, periodic table number 35.5 plus 1, will give you 1.24 moles of HCl, the actual substance. All three of these require moles of the solute on top, 1.24 moles, 1.24 moles, 1.24 moles. The volume for the molality, the volume of the solution we assumed was 100 cubic centimeters, so that would be 0.1 liters. Do the math and you get 12.4 molar hydrochloric acid. The molality is kilograms of the solvent. Well, 119 grams is the total mass. Of that, 45.22 grams is the hydrochloric acid. So subtract those, you get 73.78 grams of water. Change that to kilograms, move it over 3 places, 0.07378 kilograms, which will give you, doing the division, 16.81 molal. The last one, you have 1.24 moles of solute, so 1.24 moles again, plus you got to change the 73.78 grams of water to moles, and that turns out to be 4.10. 1.24 divided by the sum of those will give you 0.232. All the homework problems are variations on these two things. That ends this lesson on concentrations.